Good evening, everyone. Mechanics of materials. Let's follow our previous example in a stepped shaft which rotate at 900 review per minute to transmit power from a turbine to a generator. In first part, we just review this problem with a radius of fillet of 9/6, and we just want to know what if we increase the radius of fillet to 15/16 in terms of shear stress, torsional torque, and also power transmitted. So to start the problem, we'll jump to the plot of a stress concentration factor for fillet in circular shaft. And then with the ratio of capital D, small d, which is 7.5 inches, and the other one is 3.75 inches. The radius of fillet is 15/16, which is 0.90, almost 0.94 inches. And if you just get the ratio of d over d, which is 2, and r over d, which is 0.25, and find that on the graph, you will get a stress concentration factor of 1.20. If you remember in part A, we get the stress concentration factor of 133. As we increase the radius of fillet, the stress concentration reduced, and it just there is a more smooth transmission of torsional torque to the other half. So to calculate the torque, now we have like a stress concentration factor of 1.20. Tau maximum is Tc over J times the concentration factor. Then definitely tau maximum is at the smaller part, which is a smaller polar moment of inertia. Tau max is by J min. So flip-flop the equation, we can get the equation jotted down for torsion, and that's J over C tau max over K. We already calculated J over C for the smaller portion of our configuration, which is 10.35 inch cubed, and based off problem statement, we have allowable shearing stress of 8 kilopound square inches. So then the second part of calculation of torsion is tau maximum over K. So replace 8 ksi over K, which is 1.20. It just gives us a 6.67 ksi. Then for calculation of tau, if we just replace the two part of the equation, like J over C, which is here, and tau maximum over K, which is here, it just gives us a 69 kilopound inch in terms of torsional torque. So as soon as we have our torsional torque, we want to calculate the power for our step shaft. Again, it's rotate at 900 review per minute. Formula for P is 2 pi frequency times T. Frequency remains the same, which we already calculated. That's a 15 hertz. And then if you jot down the equation of power and then convert it to horsepower, that gives us a power of 985 horsepower. If you make a comparison between the previous part in previous video, you can easily see by increasing the radius of fillet, torsional torque increase from 62.3 to 69, and also horsepower from 890 to 985. And the reason for that is why T4B is bigger than T of A, why the torsion at part B is higher than the torsion at part A, which is here. The reason for that is the formula for torsion is J over C tau max over K. As soon as K reduced, as you can see, by increasing the radius of fillet, stress concentration factor decreases, and that's logical because the transmission of torsion can make it smoother to the other half. Then torsion is increased, then that's why T sub A is smaller than T sub B. And the reason why the power at part B is bigger than power at A. The reason for that is power has a direct relation with torsion. So 2 pi times frequency remains the same. The only difference is increase in torsion. So definitely power will increase by a increase in the radius of fillet. So again, a small increase in radius of fillet at the at the transition in the shaft produces a significant change in the maximum power transmit. So our radius of fillet increased from 0.56 to 0.93, and the maximum power transmitted increased by almost 11%. And that's a big change in terms of power transmission. So again, you can also consider the problem. What if we have like the same torsion, if torsional torque at A, which is here, is equal to torsional T at B, and both of them are equal to T. The only change is radius in fillet from 9/16 to 15/16. In that case, as we discussed, K, or stress concentration factor, for the first part is 1.33, and for part B is 120. And in tau formula, in shear stress formula, as soon as K reduced, the an increase in the fillet reduces the radius of shearing stress. So if the torsion is remains the same, by increasing the radius, we can have like a shearing stress reduce in our case. Thank you. We'll solve more problem in shafts.